Good morning, students. We are now on the second week of our module. I'm Mr. Mhervin Marasigan from the Mathematics Department of Payapa National High School. So for this week, we're going to discuss about the special type of sequence. But before that, let us check first your logical thinking skills. So I prepared 3 sets of sequence. So the first one, what is the next shape? Heart, square, 2 hearts, square, and 3 hearts. What do you think is the next figure? Your answer must be a square. We have 1 heart, 1 square, 2 hearts, 1 square, 3 hearts. So the next figure is a square. How about this one? What is the next number? 5, 15, 25, 35. The next number after 35 is 45. And the last, what is the next letter? A, B, D, G, K, and blank. The next letter after K is letter P. Upon analyzing, A is the first letter in the alphabet, B is the second, D is the fourth, G is the seventh, K is the 11th, and P is the 16th. To get the second letter, we add 1. To get the third letter, we add 2. And then we add 3, we add 4, and to get the last, we need to add 5. That's why the next letter is letter P. So I think you are now ready for our discussion for this week. So this will be our learning goals. The first one, illustrate an arithmetic sequence. Second one, determine nth term of an arithmetic sequence. And the last, determine arithmetic means of an arithmetic sequence. For our exploration number 1, I have here sequence, a set of sequence, 15, 20, 25, and 30. What do you think is the next number? Upon analyzing, we add 5 to get the second. To get the third, we also add 5. To get the fourth, we need to add 5. And for the last number, following the pattern, we need to add 5. That's why the next number after 30 is 35. As you can see, we have the same addends, which is 5. These 5 are what we call common difference. And if the sequence has the common difference, this sequence is what we call arithmetic sequence. Again, arithmetic sequence is a sequence with common difference. So this is the definition. It is a sequence where each succeeding term is obtained by adding a fixed number. The fixed number is called the common difference, which is denoted as D. Let's try this one. On the given sequence, 10, 13, 16, and 19, is it arithmetic or not? The answer is arithmetic sequence. Why? Because there is a common difference, which is 3. How about this one? 2, 6, 18, and 54. Is it arithmetic or not? The answer is not arithmetic because there is no common difference. And the last, 57, 49, 41. Is it arithmetic sequence or not? This sequence is arithmetic sequence because there is a common difference, which is -8. So we are done with the learning goal number 1, illustrate an arithmetic sequence. Let's now move on to learning goal number 2, determine the nth term of an arithmetic sequence. For our exploration number 2, let's use again the sequence. 5, 15, 25, 35. We can easily identify the fifth term, which is 45, by using the common difference. So fifth term is 45. How about the 10th term? Can you do it manually? How about the 50th term? Can you do it manually? And how about 125th term? Can you do it manually for 1 minute only? Of course not. That's why I'm going to introduce to you the formula for the arithmetic sequence. So this is the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the last n term, a sub 1 is the first term, n is the number of terms in the sequence, and d is the common difference. Let's try this example. Determine the 10th term in the sequence 4, 6, 8, and 10. Let's use this formula. A sub n is equal to a sub 1 plus n minus 1 times d. We are asked to get the a sub 10. So we have a sub 1 is equal to 4, which is the first term, plus our n is 10. We have 10 minus 1 times our common difference is 2. Recall the rule of PEMDAS. We need to perform the operation inside the parentheses first. So copy 4 plus 10 minus 1 is 9 times 2. Again, for the PEMDAS, multiplication before addition. So copy 4 plus 9 times 2 is 18. So our a sub 10 is 22. Let's check if our answer is correct. After 10, the next number is 12, 14, 16, 18, 20, and 22. Let's check if 22 is the 10th term. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. First, second, third, fourth, fifth, sixth, seventh, 8th, 9th, and 10th. So our answer is correct. So we are done with the learning goal number 2. Determine the nth term of an arithmetic sequence. Let's now proceed to the last learning goal. Determine arithmetic means of an arithmetic sequence. So to illustrate, I have here a sample sequence. 10, blank, blank, and 19. As you can see, there are 2 blanks between 10 and 19. These 2 blanks are what we call arithmetic means. For example, find 2 arithmetic means between 2 and 8. So first, you need to illustrate the given. We have 2, the first arithmetic mean, the second arithmetic mean, and the given, which is 8. We all know that 2 is the first term or a sub 1, 8 is the fourth term or a sub 4. Again, we will use this formula. For our a sub n, the last term, it is given, which is a sub 4. And then copy the remaining formula. Substitute our a sub 4 or the fourth term. We have 8 equals our first term is 2 plus, again, our n is 4. So we have 4 minus 1, and we do not have the value of d, which is the common difference. So remain as letter D. So copy 8 equals 2 plus 4 minus 1 is 3. Multiply it by d. You need to recall the rule of PEMDAS. Perform first the operation inside the parentheses. That's why we first operate 4 minus 1, which is 3. To get the value of d, we need to subtract both sides of the equation by 2. So this will become 8 minus 2 equals 2 minus 2 is 0. So the remaining number is 3d. So 8 minus 2 is 6 equals, copy the 3d. Divide both sides by 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. So our D is 2. Let's use the common difference of 2 to get the two arithmetic means. So we have 8 minus 2 is 6. 6 minus 2 is 4. And 4 minus 2 is the given, which is 2. Therefore, our two arithmetic means between 2 and 8 are 4 and 6. So this is the learning goal number 3. We are done. Determine arithmetic means of an arithmetic sequence. So that's all about arithmetic sequence, the end term, and the arithmetic means of an arithmetic sequence. With that, thank you very much for listening and happy learning.